What is an operating system? An operating system, OS, is software that acts as an intermediary between computer hardware and the user. It manages hardware resources and provides common services for computer programs. Essentially, it allows you to interact with your computer without needing to understand the complex code that makes it run. Key concepts of an operating system. 1. User interface, graphical user interface, GUI. Most modern operating systems like Windows, macOS, and Ubuntu provide a graphical user interface. This means you interact with the OS using windows, icons, and menus. For example, when you click on an icon to open an application, you're using the GUI. Command line interface, CLI. Some operating systems, especially for servers or advanced users, offer a command line interface. Here you type commands to perform tasks. For example, in Linux, you might use the command ls to list files in a directory. 2. Kernel. The kernel is the core part of the OS. It manages system resources such as the CPU, memory, and devices. It acts as a bridge between applications and the actual data processing done at the hardware level. Example, when you open a file, the kernel manages the data transfer from the storage device to the application. 3. File system. The OS manages how data is stored and retrieved on a disk. It organizes data into files and directories. Example, on your computer, you might have a directory named Documents where you store text files and spreadsheets. The OS keeps track of where each file is stored on the disk. 4. Process management. The OS manages processes, which are instances of programs in execution. It handles process creation, scheduling, and termination. Example, when you open a web browser and a text editor simultaneously, the OS allocates CPU time to each process so they can run concurrently. 5. Memory management. The OS manages the system's memory, ensuring each process has enough memory to execute and that different processes do not interfere with each other. Example, when you open multiple applications, the OS ensures that each application gets a fair share of memory and that they don't overwrite each other's memory. 6. Device management. The OS manages device communication via drivers, which are specialized programs that translate the OS's generic commands into device-specific actions. Example, when you print a document, the OS uses a printer driver to communicate with the printer and send the document in a format the printer understands. 7. Security and access control. The OS protects system resources and data from unauthorized access and provides authentication methods like passwords or biometrics. Example, when you log into your computer, the OS verifies your username and password to ensure you have the right to access the system. 8. Networking. The OS provides networking capabilities to enable communication between computers over a network. Example, when you browse the internet, the OS handles the data exchange between your computer and the web server hosting the website. Real-life use cases of operating systems. 1. Personal computing. Example, your personal laptop running Windows 10 allows you to write documents, browse the internet, and watch videos. The OS handles file storage, internet connectivity, and device management like printers and webcams. 2. Smartphones. Example, Android and iOS are operating systems for smartphones. They manage calls, messages, apps, and hardware like cameras and sensors. When you use your phone's GPS for navigation, the OS coordinates the GPS data, maps, and user interface. 3. Servers. Example, a web server running Linux might host a website. The OS manages network requests, serves web pages, and ensures security through user access control. 4. Embedded systems. Example, an embedded OS in a smart thermostat controls heating and cooling systems, processes sensor data, and allows you to adjust settings via a mobile app. 5. Supercomputing. Example, supercomputers use specialized operating systems like Cray OS to manage complex simulations and data processing tasks for scientific research. Detailed explanation with simple words. Imagine your computer as a large office building. The operating system is like the building's manager. User interface. Think of this as the reception area. You can either talk to a friendly receptionist, GUI, or use a help kiosk, CLI, to get information. Kernel. This is the manager who knows everything about the building and ensures all systems work smoothly. They decide who uses the meeting rooms, CPU, manage the janitorial staff, memory, and keep everything running efficiently. File system. This is the filing room where all documents, files, are stored in cabinets, directories. The manager keeps an index of where everything is. Process management. Imagine multiple teams working on projects, processes. The manager allocates meeting rooms and resources to each team, ensuring they don't conflict. Memory management. Similar to allocating space in a meeting room. The manager ensures each team has enough space and that their work areas don't overlap. Device management. This is like the maintenance department, ensuring all equipment, printers, scanners, works correctly. Security and access control. Think of security guards who check IDs and ensure only authorized people enter the building. Networking. This is the communication system, like the building's internet and phone lines, allowing teams to communicate with the outside world. In summary, an operating system is the essential software that makes your computer usable, managing all the hardware and software resources, and providing you with a user-friendly way to interact with your machine.